Okay, so what we have here is a thermoelectric cooler, which is a really common and cheap, easy to come by tool to make things really cold or really hot. They're commonly found in wine coolers and the kind of like portable, like plastic box coolers you might find in your car and stuff like that. They're really lightweight. They're not too efficient, but the reason I'm talking about them today is because what's interesting about them is that they don't have a set temperature that they like to operate at. They just provide a change in temperature. So what I'm about to show here is, what I made here is, if you can come closer, what I've made here is a thermoelectric cooler underneath this plate here, and this is a small, just like machined aluminum plate, and a heatsink, and this is the thermocouple on top. And there's another thermocouple I've placed in the water. And so when I turn this on, what should happen is that the temperature should drop by somewhere in the ballpark of 25 degrees. And so right now in here, it's 14 degrees centigrade. It's kind of a colder room. And so the target we're looking for right now is probably somewhere in the ballpark of -10. Of course, once this water heats up, it's probably gonna be a little warmer, but we'll give it a shot and let's see what happens. So let's plug it in. Okay, so now it looks like the temperature might start climbing in the water, but we're at -11 degrees centigrade. So, not far off from an original predicted value of -10. That's pretty good. And the water's at about 12 degrees centigrade. And so in this case, at 12 volts and at 5.4 amp power draw, we are getting an approximate temperature drop of -24°C. And so what I'm going to do now is I will add a bit of ice here, drop the water temperature by another 12 degrees. Cool. Okay, so I changed out the water. Now we've got a lot of ice and water in there together. And the readout on the thermocouple is about 1 degree centigrade. It's pretty close to freezing. And so what I'll do is I'll plug this in again. Get it going. I'll see how it drops. Alright. Okay. Cool, so I threw a little insulator on here. Quite warm to the touch. We're down to -20, -21. Alright. 3 degrees to go.
Yay.
We're officially at a -24. We're trying, well, at -23. That is a full -24°C difference, which means that we have a linear temperature shift from the original roughly 12, 14 degree range to the 1 degree range. So the theory stands that as we get colder, so as we get colder to like a chest freezer minimum temperature of about -50, if we really want to hit that -70 degree temperature, all we have to do is get a bunch of these TEC coolers and put them in a chest freezer or a deep freezer or a tuna freezer, and that should allow us to get there pretty easily. Thanks. So looking through Amazon really quick, there appears to be a number of different options just called electric coolers. I've used one of these before, and most of these are probably going to be just fine for this purpose, but ideally what I'd like to do is take one of these relatively affordable thermoelectric coolers and place one in a deep freezer of some sort to see just how cold can we get on the inside of one of these boxes. If anyone has one of these lying around and they happen to have an open or a walk-in freezer, that would be a really cool test. And so, the reason I'm mentioning all this is because a, a few months ago, the lab I was working at ran out of dry ice, and kind of came out of nowhere. And the system that supplied all the dry ice in our area, um, one plant for all of Boston, and this is a pretty well-resourced lab. It was down for about a week. So there's a whole week where our experiments were warming up, and it was quite harrowing. So I'm not super concerned that will actually happen again. I hope they're planning ahead quite well. The Pfizer teams that are making these vaccines and others, but regardless, I hope that this might be helpful to someone in a pinch if it comes down to it.